Hello everyone, we are going to start our presentation. We are talking about our development of an integration of a BIM solution with geographic information systems applied for real project substations. Our system is applied for electrical sector, especially in Brazilian electrical sector. Our work proposed the integration of these two technologies since in previous experience in other engineering areas and fields have shown promise advances that could be useful for management and maintenance for electrical power markets. By associating these two technologies, an accurate mapping and accurate designs can be provided as never achieved before. And the information related to disaster assessment, cable, electronic components are integrated with high accuracy and bring information of the complete company informations, turning to reality capability to work as a team, as a group. In this slide, we can provide to present for you a substation of a big hospital in Brazil, all designed in 3D using build information modeling. This cabin of electrical substation is provided with 4 transformers. These transformers has information in this screen you can see on the right side. You have a lot of information that can be provided a better understanding for the designer at the time of design or time of the project. At the time of project, the amount of information, the accuracy of information is very important to good sense of the design and to reduce the cycle of the project, to reduce the mistakes, to reduce the collusion of the other disciplines of design with parametric information of each component you can see on the screen, like a busway walk through on the building, the possibility to clash detections, the possibility to detect interference with water, with gas, with firefighters, infrastructure, or any kind of disciplines at the time of design, providing better final results and accuracy optimized. Okay. Another thing we need to talk about is the capability to work as a team, because with this kind of tool it's possible to work with a team. With this team it's possible to work with different kind of people, like architects, like providers, contractors, electrical engineers, civil engineers, mechanical engineers, anyway. And these informations are shared with specific details for each part, providing better understanding, providing better collaboration between each other, provide simultaneous engineering work, providing better multidisciplinary capabilities, and increasing the quality of the project, increasing the quality of design, increasing the quality of the final results. And in this figure, we present a lot of people always talk about different levels of BIM. But what they really actually mean? Well, the levels run from 0 to 3 and are used to measure the BIM maturity. Is the construction supply chain ability to operate and exchange information. Level 0 is essentially the use of computer-aided design or CAD tools, old CAD tools. to create drawings. As drawing elements using IT software, it's the first step for generating information by hand. By contrast, levels 1 to 3 deal with varying degrees of modeling, corroboration, and eventuality interoperate data. The 3D model simply designed in 3D is called model not federated or non-federated. Model non-federated are located only in level 1. The federation possibility takes the place within a capability to share information online area known as common data environment. In broad terms, level 2 is defined as a file-based collaboration and library management levels. Level 1 and Level 2 are supported by various guidance documentations available online. Level 2 envisages the whole integrated project information model hosted and fully developed in a common data environment by all members of the project team in real time. That model could then be passed to the employer for use in lifecycle management as an asset information model. At level 3, the 3D drawn attribute data can be included with 4D as a time, 5D as a cost, 6D as a facility management capability. So, in geographic information system, these kind of systems are very old and has a long time operation information assets in GIS organizations like Furnace. Furnace today provide over GIS informations five key informations: people, data, process, policy, strategy, technology, and legal information. When you implement an integration with GIS solutions, you have condition to access this kind of information. These informations are very strategic for our workflow. The workflow is presented in this picture. Associating GIS and BIM, we have together geographic information of each project component, of each electrical component of the substation, joined with ERP solution or SAP, depends on the company. These non-geographical informations are mixed, turning into reality the classification of BIM in level 3, with 3D, 4D, and 6D information of electrical components working as active elements or are really digital twin characteristics. When you implement a BIM platform, BIM have informations we call capital projects because have preliminary design and plan, followed by a detailed design, followed by a pre-construction phase, followed by a construction phase, and finish with a documentation. When you are talking about with GIS, GIS has or is composed by capital portfolios, services followed by monitoring and enforcement, followed by revenue generation, followed by master planning, followed by regulation and permitting. Joining these two kinds of informations is possible to have a very different and very powerful tool and very environment tool. In the next figure, we present the parts what we are doing inside Furnace company. The implementation is divided in these parts. These parts are composed by two technologies. In one side, BIM side, we are using Autodesk solutions. In the GIS solutions, we are providing ESRI technologies. Together, we can explain each part. In the left side, we can see the inventor environment. The inventor environment provides electromechanical components modeling as a parametrical parts. Okay, these parametrical components are created as a family and can be used inside Revit desktop application, customized application inside Revit, especially to model and create substation designs. This model can be accessed also inside the Forge technology, Forge environment. This kind of integration can be used inside desktop as a Revit customized or inside Forge. That's where inside Forge is possible to integrate with ArcGIS, that's GIS application, that can access inside SAP directly. This application is called GIS Connect, and access Furnace ERP corporate database. Okay, over the web. In a cloud, we are developing a GIS and BIM integration. This integration in the design stage, possibility to use ArcGIS and GIS Connect to access SAP. In early stage, we connect GIS and BIM, enriching the BIM family with scalability and strategic information provided for the user in different contexts. Here we present a transformer, a parametric transformer. This transformer is completely modeled as a parameters, and its parameters, some of them are in 3D, are constructed of electromechanical informations, geometric, and then other informations are bringing directly for SAP using GIS technology. So at the design time, I have GIS information to take me better conditions to take more precision decision makings. We are assessing and add more complex design, turning possible to improve the project workflow, optimize the whole process design process. This next figure, we can access the SAP Delec with BIM design tool. This interface is accessed by web solution Autodesk Forge or use a customized Revit interface desktop. At this slide, we can view a transformer used included over a GIS database, inserted in a GIS real coordinates, and reading in real time the SAP ERP database provided by GIS Disconnects solution. This platform works over a desktop and over a cloud solution, published together as a GIS database and BIM project working together. In conclusion, the integration we propose provide a better collaboration, improve productivity, improve coordinate, reduce costs, turn the management more accurate, and complete avoid incompatibilities, integrate innovations, reduce life cycle, and elevate the accuracy of many upgrade processes or substations. Open the future possibility to implement the BIM design with the capabilities of management and operation area, OEM. Provide innovation in this area using the successful BIM applied for civil engineering for electrical area. Bring the reality to reality the digital transformation for Brazilian electrical sector, special for electrical transmission area in Furnace government company. We would like to express our thanks for sponsors CAPES, PAPEMIG, CNPq, Furnace, and Federal University of Uberlândia. Thank you very much for attention.